So the new Smart Edit functionality incorporates the Smart Join functionality, but in doing that we've also incorporated 3D functionality into all of the edit modes. So now you have break, trim, extend and join as three different modes of operation in Smart Edit. If we pick the join functionality to start off with, you can enable 3D editing or not, and that just enables the 3D searching or not in the functionality. So basically it enables 3D editing or disables 3D editing. So in other words, if you say it's only 2D, it will only join lines if they're two-dimensional. But if you say enable 3D edit, then it has to do all the 3D edit checks. So just be aware that when you pick 3D editing, it can make it a little slower to do some of the calculations in some situations. Then you can apply 3D edit rules, and the edit rules have been defined so that you can really control how you want lines to join in 3D space by default. So if I go up to the RPS settings, we can go to the 3D edit settings here, and we can take a look at the options that you have available now in 3D edit rules. So you can create as many rules as you want. So here you can see I've got a number of different rule types that I've defined. In here you can give them a description, so it just gives you an idea of what that rule type does. And then you have, these are your main controls here. So the first thing is, when you have a line with vertical curves, what do you want to happen if you decide you want to break it at the point where the vertical curve is? So typically in TBC it doesn't let you do that. So what we've done is we've engineered a new solution here so that if you decide to break a line at a vertical curve, you can decide that you want to break it at the vertical curve breakpoint, which is maybe in the middle of the vertical curve, in which case we calculate two new vertical curves to closely match the geometry of the original vertical curve, and let you do exactly that, break where you want to. Or you can decide that you're not allowed to break at a vertical curve, so it will tell you can't. Or you can say, when you pick a point in a vertical curve, always break it at the start. That means the whole of the vertical curve is in one half of the line. Or you can say break it at the end of the vertical curve. So you can decide which mode you want to use here. The second function is to do with VPIs. This allows you to say that if you join or trim and extend lines which have VPIs on them, when you do that you want to convert all the VPIs to 3D nodes. Now it can do that for the elevation nodes, but it leaves behind the vertical curve nodes and nodes that are defined by inbound or outbound slope, because we figured those are things that you want to retain most likely, and the vertical curves, obviously we treat those with the break functionality up here. The next option is to do with how do you want to join when you trim and extend to a join location, or you join two lines at a specific location. How do you want to define the elevation of the point where the two lines come together? Obviously there's more than one option here, so you can choose from any of these options. So you can say always take the slope or the elevation from line 1, always take the slope and elevation from line 2. You can take the mean of the inbound and outbound slopes, so basically it will find the mean slope or the mean elevation between the 2 points. Take the highest elevation of the two lines, take the lowest elevation of the two lines. And the last option there is user-defined value, or select one from a computed set of values. Now I prefer this option here because it gives you all of the options from above, and you can choose at the time of execution as opposed to picking one by default. But if you always want the mean for some reason, then you can come up here and just always pick the mean, for example. The next one is what happens when you want to join a 2D line to a 3D line. How do you want to handle that? And the option here is to, when you take the 2D line and add it to a 3D line, if you say use the extend vertical option, then whatever the slope of the 3D line is where it joins up with the 2D line will be extended all the way out to the end of the 2D line to give it elevation control. Or you can say in here that you don't want extend vertical applied, or you want to make the whole line 3D, the whole line including the 3D segment 2D after the join. So you can choose which method you want to use here. And then remove unnecessary nodes. This is a function where if you have, for instance, piles that are defined by more than 2 nodes, so you've got 3 points in a straight line or 4 points in a straight line, the calculations are only applied to the last segment, and if the breakpoint happens to be in the middle segment, for example, then it won't function. So in here you can say clean 3D nodes, and what that does is it basically takes the middle nodes out of the line if they're all in a straight line. So if you've got 3 or 4 points forming a straight line, it will turn it into a 2-point line, and that way you can then trim and extend or break it at a surface or whatever you're trying to do, without having to worry about whether it's breaking through that last middle node or whatever. So you can say maintain the 3D nodes. Typically that's the way you want to work, but if you really want to clean 3D nodes, you can do that while you're doing it. Now it does the cleaning before it does the calculation, so in some situations that may or may not give you the most desirable answer. So typically leave it at maintain 3D nodes unless you find that the trim or extend functionality isn't working, in which case you can then change this to clean 3D nodes to make it work. So once you've defined your rule sets here, you can then say OK. And next thing is we're going to do is we're going to go into the join functionality. We've picked our 3D rule set here, and we can now say what do we want to do here. So I'm going to say join at intersection point for this example, and we can say between these two lines, for example. And so we're going to say if we have a crossing over here, we're going to use a crossing point, but to start off with we're not going to do that. And in this case we're going to find the intersection between these two, so I'm going to allow the maximum join distance to be greater than the maximum I've got for any of these lines, and this one over here is about 100 feet, so I'm going to let it go to 100 feet. And we're going to leave these other settings alone, and we're not going to choose any of these. And now we're going to say what do we want to do. So we're going to use single mode, which is the same as it always has been in Smart Join, which would add an extra segment in between these two. Now in this case we're using intersect, which means it's going to find a single segment to here and a single segment to here to find the intersection point. Now these two options here are new, and we'll cover those in a few minutes. Those are for elevating and relayering lines. So if you're joining contours or building pads and things like that together, then you can also decide you want to relayer and set elevation. You've got a set of elevation rules here that you can apply. In this case we're just doing straightforward joins. So we're going to say pick the source line. This is a 2D line, so you can see some of these lines are elevated, some of them aren't. These are both 2D lines. So what happens when we join two 2D lines together? So we pick this, it just trims to the intersection and sets the intersection point to be 2D. Okay, but let's go to this one where we've got two 3D lines, and we've got obviously this one, if I project it to here, this elevation would be at 104. If I look down here, this one would be at an elevation of about 114 or 113. So we've got more than one option for elevation at the intersection point. So how do we handle that? So with the method we've selected, which if you remember up here, I selected this method, use a user-defined value. Now this is where this applies. If I said use the mean value, it would always use that. But in this case, I'm going to use this option because I think this is the best option that you have. And now you can pick the source line and the target line. And what it does, it pops up a little dialog here and says, okay, if you project line 1 to that intersection point, the elevation will be 103.32. If you project line 2 to that point, 114.37. So the highest of those two is 114, the lowest is 103, and the mean is somewhere in between. Or you can define a user-defined value, and in here you could say leave it undefined, in which case there would be a continuation of slope between this elevation and this one, so it would just do a smooth slope between these two. Or you could say no, I don't want any of the above values, I want to type in a specific value, and it would then set the point here at that value. But in this case I'm going to say let's hold the slope of this line, so we're going to do this and say OK. And so what it does is it adds you an elevation point of that elevation. So this slope is continued, but this one here obviously is going to get steeper between here and here into that point. So whichever method you pick, you get to control the elevation of the join location. Okay, let's move to this one. This is a crossing line, so we're going to use crossing point here. And again, the same thing applies here. We pick line 1, we pick line 2, and it says these are all the options for the crossing point. What elevation do you want at that point? So you can see here you've got 107.43 from line 1, 107.99 from line 2. Then you can say, well, I'm going to pick the mean value in this case, which is halfway in between these two, and then say OK. And so now it's added 107.71 at that location. Now the other thing to mention in here is when you've got crossing lines, which two pieces of the lines do you want to keep? So whichever segments you pick, in this case, it's going to take those two segments and make you a reference line out of those two. So if you pick these two up here, it will create you that line between those two, etc. So you can pick the segments you want when you're joining, when the lines cross over each other, or there's some ambiguity as to which piece of line you might want to keep at the end. When you take a 3D line and join it with a 2D line, this is where the extend vertical comes in. If you remember up here, we said when you join a 2D line to a 3D line, extend vertical. That basically means that the extend vertical flag will be added to the lines, and the vertical of the 3D line will be transitioned into the 2D line all the way to the end. So in this case, what I'm expecting to happen here is that the point here will be undefined, where you can choose it, and then it will project all the way down with the extend vertical. So it does have an elevation, and the extend vertical flag will be enabled. So we can click on the line 1, click on line 2, and it says, okay, line 1 has an elevation at the intersection point, so we can project this slope all the way down to the intersection point, but then from there on we don't know any elevation. So we can say, okay, that sets the elevation to this point. And if I now look at the line properties, now how do you get to the line properties? That's another little feature we've added in here. If I do Shift M, it pops up this little menu here, and I can say, let's take a look at the properties pane, and you can see that the extend vertical has been enabled, and it's been projected all the way to the end. So what does that really look like? Again, if I do Shift M, I can look at the profile viewer, and that shows me the profile view for that line all the way down, and you can see it's holding the slope of the last segment here, and it's projecting that all the way down to the end of the line here. So other things that you can do with that Shift M menu is you can pop it up and you can turn on the rock grip. So if you want to edit the line, you can come in here and you can now start making edits to the line, and then you can do Shift M again, and if you want to show the direction of the line, you can show the line direction. So that shows you the line directions on the line itself. Shift M again. You can close the line should you want to do that. So close it out. I'm just going to undo that. So you've got all the things on here, like edit line string is on here. You can go in and change the line string, and when you hit escape, it's back at the command ready for the next function. So we've added this Shift M menu to give you access to the things that you typically want to find while you're doing that, which is similar to doing the things at the header bar here, but it just gives you control, especially when you've got multiple selection sets going together. So we have line 1 and line 2 selections, which is not just a single selection. So in this case we have to use this kind of technique rather than this up here to do this kind of calculation. Let's take this example. This is another example where we've got a 3D segment here and a 3D segment here, but these are 2D segments from here to here and here to here and here to here and here to here. So what is the intersection elevation at this point? So when we pick this point right here, I can say pick this one and this one, and it says, well, okay, if I calculate the projected segments, the last two segments, there is no elevation for that. So what elevation do you want to put on that point? I can keep it as undefined and set it to user value here and say OK, and that will set the undefined value here. Maintain the elevations of the points you've got and project the slope of this one down to here all the way through to here and out. So again, if I look at the Shift M menu here and look at the profile viewer for that line, that's now the profile view for that line, and you can see that it's locked in the elevation of 109, locked in the elevation of 103, and just put a straight slope between those two, which is somewhere in between the slopes of these two lines. So it kind of evens out the slopes throughout all the way down to the end of the line. So these are your Smart Edit, Smart Join modes, and the same applies when you trim to an intersection. That's basically using the same technology, and it allows you to manage your slope controls and your elevation controls in a better way. Now, when the other things that you've got in here, I'm going to come back and talk about the relayer and set elevation functions as well, because those are tremendously powerful tools when you're doing takeoffs, and we'll come back to that in just a second.